students, I hope all of you are doing good. Let's start today's chapter, Understanding Elementary Shapes. In this chapter, we're going to learn about or we're going to talk about these topics, right? First, introduction. In the previous chapter, we have learned about some basic geometrical concepts such as line, array, line segment, angles, triangles, etc. In this chapter, we are going to learn more about these geometrical shapes, how to measure them. We shall learn about three-dimensional shapes also, such as cube, cuboid, and also the comparison of these shapes of different sizes. Okay. 5.1 Measure of line segments. Line segment AB is a portion of a line which has fixed endpoints. Since ends of the line segment are fixed, it has a fixed length and it can be measured using a ruler. However, for comparison of line segments, we have three ways. Number, comparison by inspection, means by just observing, by just looking. Okay. Number two, comparison by tracing, and number three, comparison by using a divider or a ruler. Okay. Remember, pencil should be very sharp, preferably H or 2H pencils should be used for geometry. Number two, for measuring any reading on ruler, position of eye should be at right angle to the reading. See, your correct position is given. Okay. Number one, comparison by inspection. Okay. Sometimes when two line segments have quite comparable measurement, we can say by observation that which segment is larger and which is smaller. Look at the following. In figure 5.21, it is very clear that length of AB is greater than length of PQ. Obviously, it is very obvious. We can observe that. And in figure 5.2, second part, if we compare just by inspection, they look of the same size, right? But when we measure them using a ruler, we find that CD is slightly smaller than EF. Okay, remember. This method is not quite convincing because when the given line segments are almost of same size, it is difficult to say which one is smaller than the other, okay, by just inspecting or by just looking at those lines. Number two, comparison by tracing. In this method, to compare the lengths of two line segments, we trace one of these line segments on a tracing paper and compare it by overlapping it on the other. Remember, this method is quite accurate, but its accuracy depends on the exactness of tracing. Okay, and so the number three, third method is comparison using a ruler and a divider to compare the line segments AB and CD. These line segments, with the help of a divider, put one of the endpoints of the divider on one endpoint of the line segment AB, say A, and then stretch its other arm so that its other endpoint coincides with B. Now lift the divider and put it on line segment CD, such that its span remains the same and its one endpoint falls on C. Now, number one, if the other end point falls before D, then the length of AB is less than length of line segment CD. 2. If the other endpoint falls after D, means after this point D, length of the line segment AB is more than the length of line segment CD. And if the other endpoint falls on exactly D, the line segment of line segment AB is equal to the length of line segment CD, right? No more. This is the best method to compare the length of two line segments accurately. B. We can also measure the lengths of the given line segments using a ruler and compare their lengths by comparing their measurements, right? Next, construction of a line segment. To construct a line segment of length 5 cm. Number one, using a ruler. Draw a point on the sheet of paper. Name it A. Now put the 0 mark of the ruler on A. Press the ruler tightly and mark a point at 5 cm. Name it B and join AB. Thus, we get a line segment of length of 5 cm. Okay. Now, B, using a compass. Draw a line L and mark a point A on it. Now, place the metal point of the compass on the 0 of the ruler and extend its other end so that it reaches to the number 5 on the ruler. Now, without changing the span of the compass, place a metal point of the compass on A and draw an arc with the pencil end on the line L. Name the point on line L by the arc as B. Thus, AB is a required line segment of 5 cm. Okay. Exercise Point 1, compare the line segments given below. Okay, so by just looking at them, we can find that these line segments are equal, but you have to compare these line segments with the help of divider, or even you can use a ruler also, right? Angles and its types. We have learned about angle in the previous chapter. An angle is formed by two rays originating from the same point. The common point of the two rays is called its vertex, and the two rays as arms of the angle. Now we will discuss about types of angles. Number 1, complete angle. When a ray, suppose OP, ray OP, makes a complete revolution, it is making a complete revolution, the angle so formed is termed as complete angle. Number 2, straight angle. When the ray, suppose OP, makes 1/2 of the revolution, the angle formed is termed as straight angle. Number 3, right angle. When a ray OP makes on 1/4, that is 1/4 of a revolution, it makes an angle termed as right angle. Okay. And acute angle. When a ray OP makes an angle which is less than 1/4 of a revolution, is called an acute angle. See, this is an acute angle, means which is less than 90 degree. Okay. Number 5, obtuse angle. When a ray OP makes an angle which is more than 1/4 of a revolution, means which is more than 90 degree but less than 1/2 a revolution, that is less than 180 degree, then it is called obtuse angle. Okay. And number 6, reflex angle. When a ray OP makes an angle that is more than 1/2 of a revolution, that is more than 180 but less than 1 revolution, that is less than 360, then it is called reflex angle. Okay. So it is to be remembered that when the ray doesn't revolve the angle, it is termed as a zero angle. For example, this ray is making an angle of both 0 degree, right? No more. Complete angle is equals to 2 straight angles. One straight angle is equals to 2 right angles. Okay, complete angle is 360 degree and 2 straight angles 180 degree plus 180 degree. Okay, one straight angle, that is 180 degree, is equals to 2 right angles, that is a 90 plus a 90, and one complete angle, that is 360 degree, is equals to 4 right angles, that is 90 degree plus 90 degree plus 90 degree plus 90 degree. Exact. It's clear. Next, measurement of an angle. An angle is measured using protractor or D. See, this is known as protractor and its shape is like alphabet D, so it is also called D in your geometry box. The unit used to represent arc angle is termed as degree. Okay, thus degree is the standard unit of measure of an angle. Let us discuss degree measure of the angles discussed above. One complete revolution is equals to 360 degrees, denoted as this. Thus, 1 degree is equals to 1 by 360 of a revolution. Thus, measure of one complete angle is 360 degree. We know one complete angle is equals to 2 straight angles. So, one straight angle means 360 divided by 2, that is 180 degree. Also, right angle is equals to the fourth of a revolution. Therefore, one right angle is equals to 360 degree by 4, that is 90 degree. Thus, one complete angle is equals to 360 degree, one straight angle is equals to 180 degree and one right angle is equals to 90 degree. Okay. No more. The name of system in which angle is measured in degree is called sexagesimal system. There are 2 more systems. See the scientific calculator. You can see 3 modes, D, G and R. D means degree, G for grades, R stands for radian. One right angle is equals to 90 degree, is equals to 100 grade, is equals to pi by 2 radians. Names of other 2 systems are centesimal system, that is grade, and circular system, that is radians. Here we will focus on angles in degree. No more. The measure of an angle, acute angle is more than 0 degree but less than 90 degree. You already know that, right? And the measure of an obtuse angle is more than 90 degree and less than 180 degree. And the measure of reflex angle is more than 180 degree but less than 360 degree. Okay. Construction of an angle. Now, let's see how to construct an angle. We can construct angles using a protractor in 2 ways, clockwise direction and number 2, anti-clockwise direction. Let us understand the same by the following examples. Construct angle of 50 degree in clockwise as well as anti-clockwise direction. Number 1, anti-clockwise direction. Draw a ray OA first with the initial point O. Place the protector on OA in such a way that the center of the protector falls on O and the base of protector lies along OA. To measure the angle along anti-clockwise direction, OA will be rotated in anti-clockwise direction. We select the lower marking such that O on protector lies along ray OA. Counting along the marker from O, mark a point B which coincides with 50 degree on the protector. Remove the protector and join OB, ray OB. Thus, angle AOB is equals to 50 degree. Is the required angle in anti-clockwise direction. Okay. Number 2 is clockwise direction. Draw a ray PQ as shown in figure 5.A, third part. Okay. With its initial point P. Place the protector on PQ in such a way that the center of the protector falls on P and the baseline along PQ. To rotate PQ in clockwise direction to form an angle, we select the upper row of marking, counting along the markings on upper row such that 0 on protector falls on PQ. Mark point R against the mark 50 degree on the upper row. Now remove the protector, draw the ray PR. Okay. Thus angle RPQ is equals to 50 degree is the required angle in clockwise direction. Okay. We compare any two angles by following methods. Number 1, by observation. Number 2, using tracing paper. Number 1, by observation. We can compare the two angles just by observing or looking at them. The smaller is the opening between the arms of an angle, the smaller will be its magnitude and vice versa. Refer figure 5.9. Angle ABC. This angle is less than this angle, that is XYZ, or you can say angle XYZ is greater than angle ABC, because opening between the arms of ABC is smaller, as you can see, than the opening between the arms of angle XYZ. But this method doesn't give accurate results, so we use other method, that is using tracing paper. Okay. Remember, in protector or D, everywhere at same point, two angles are written, like 50 degree and 130 degree, 70 degree and 110 degree. Their sum is 180 degree. That is 50 degree plus 130 degree is equals to 180 degree. Similarly, 70 degree plus 100 degree is equals to 180 degree. You are familiar to write 90 degree or right angle. See the opening arms. A. If it is less than right angle, it will be 50 or 70 respectively. B. If it is more than right angle, it will be 130 or 110 degree respectively. Okay. Now, next method is using tracing paper. We can also compare the angles using tracing paper. For example, trace one of the angles, say XOY, on a transparent sheet of paper. Place this tracing on angle PQR such that the vertex O falls on the vertex Q and arm OX along OP, right, this OP. Refer figure 5.10. Then arm QR or ray QR can have of the following positions. A. Ray QR falls along ray OY, right. B. Ray QR is between rays OX and OY. And C. Ray OA falls between ray OR and ray OX. Okay. In case A, we say that angle XOY is equals to angle PQR, and in case B, we say angle XOY is greater than angle PQR, and in case C, we say that angle XOY is less than angle PQR. Okay. Example 1. What a fraction of a clockwise revolution does the R hand of a clock turn through when it goes from 3 to 9? Okay. See the clock, it is moving from 3 to 9. So it has made a one straight angle, or you can say half of a revolution. Okay. So half of a revolution is equals to one revolution is equals to 360 degree, right? And when you will divide this, you will get 180 degree. Okay. Similarly, in this part also 7 to 10, see, 1/4 of a revolution, that is 1/4. So 1/4 of a revolution, that is 1/4 of 360 degree, is equals to 90 degree. Okay. Now let's do exercise 5.2. Classify the following angles by just looking at them. This is acute angle because it is less than 90 degree. This is obtuse angle. This is acute angle, and this is a reflex angle. Okay. Perpendicular lines. When two lines intersect and the angle between them is a right angle, then such lines are called perpendicular lines. If a line AB is perpendicular to CD, it is denoted as AB perpendicular CD. Now let us try to find some perpendicular lines around us. Observe the position of minute hand and hour hand of clock when it strikes a 3 or 9. See this position and this position as well. Do you see that angle between the hands of a clock at these time is a 90 degree? That is, the two hands are perpendicular to each other. Okay. Now observe the English alphabet L. Does it form a right angle? Yes, it's forming 90 degree angle. Okay. Can you find out some more examples from your surroundings where you can find perpendicular lines? One such can be the edges of a tabletop. Okay. Perpendicular bisector of a line segment. Let PQ be a line segment. Now mark its midpoint M. At M, draw an angle of 90 degree. Okay, and mark it A. Now draw a line AMB. Okay, this is thus AB is perpendicular to PQ. This is line segment and this is also line segment. Okay, and also AB divides PQ into two equal parts. This AB is also called perpendicular bisector of line segment PQ. If AB is taken as line L, can we have perpendicular bisector of a line L? Think why or why not? Okay. Let's do exercise 5.3. Number 1. Observe the adjacent edges of two set of squares in your geometry box. Okay. Do they have any perpendicular line segment? And how many right angles each one has? Observe and write it down. Okay. Now let's talk about triangles and their classification. We have already studied about the types of angles on the basis of sides. Let us revise it. A. According to the sides of the triangle are: number 1, scalene triangle. In a triangle in which all the three sides of a sides are of unequal length is called a scalene triangle. Okay. Number 2, isosceles triangle. A triangle in which two sides are of equal length is termed as isosceles triangle. Number 3, equilateral triangle. A triangle in which all the three sides are of equal length is termed as equilateral triangle. Okay. Number B. According to angles, triangle can be classified as given below. Number 1, acute angled triangle. A triangle in which all the three angles are acute, that is less than 90 degree, is called an acute angle triangle. For example, this is an acute angle triangle. Number 2, right angle triangle. A triangle in which one angle is a right angle, that is one angle measures 90 degree, is called a right angle triangle. See, this is a right angle triangle. Okay, in a right angle triangle, the two sides forming a right angle are called legs, and the side opposite to right angle, that is, this is the longest side and is called hypotenuse. Okay. Number 3, obtuse angled triangle. A triangle in which one angle is obtuse, that is one angle measures more than 90 degree but less than 180 degree, is called an obtuse angle triangle. Okay. We can do a simple exercise to find the relation between triangles classified on the basis of sides and angles. First, draw a scalene triangle ABC where AB is not equal to BC and is not equal to AC. Now measure angles A, angle B, angle C of this triangle. You will find that none of them is equal. That is, angle A is not equal to B, is not equal to C. Thus, if sides of a triangle are unequal, then so are its angles. Okay. If sides are unequal, then their angles will be unequal. Right. Now draw an isosceles triangle PQR such that PQ is equals to PR. Now measure, see, this is PQR. This is isosceles triangle whose opposite sides are equal. When you will measure angle Q and R, you will find that both these angles are equal. So we can conclude from here that if two sides of a triangle are equal, then angles opposite to these two sides are also equal. You can verify that in an equilateral triangle, all the three angles of equal measure, such being 60 degree. Thus, an equilateral triangle is also called equiangular. Okay, exercise 5.4. Number 1, name the triangle in the following case. Okay, you have to draw a triangle ABC, and AB should be 4 centimeter, BC is a 3.5 centimeter, and AC is 5 centimeter. Okay, so with the help of a ruler you will draw this, right? No more. Number 1, if sum of two adjacent angles is a 90 degree, then they are called complementary to each other. Okay, if sum of two adjacent angles is 180 degree, then they are called supplementary to each other. Okay, quadrilateral. A quadrilateral is a four-sided closed figure, or it is a polygon with four sides. Number 1 is a rectangle. Its characteristic, both pairs of opposite sides are equal and each angle is of 90 degree. Square, all four sides are equal, you know that very well, and each angle is of 90 degree. Parallelogram, both pairs of opposite angles are equal and both pairs of opposite sides are equal, means this side is equals to this side and this side is equals to this side. Okay, rhombus, all the four sides are equal and opposite angles are equal. And trapezium, only one pair of opposite sides are parallel to other is non-parallel. Okay, these two sides are parallel and these two sides are non-parallel, right? Polygons. A polygon is a closed plane figure bounded by 3 or more line segments. According to number of sides, polygons can be classified as given in the following table. See, name of the polygon is a triangle, number of sides it has a 3. Okay, and number of diagonals, there is a formula n and then in bracket n minus 3 by 2. Okay, so triangle, it has no diagonal. Okay, quadrilateral, it has 2 diagonals. Now pentagon, let's apply the formula n minus 3, 2. What is n? N means a number of a side. So in pentagon there are 5 sides, 5 minus 3 by 2. So 5 into 5 minus 3 is 2 by 2. 2 goes, answer is 5. So there are 5 diagonals, right? Let's do exercise 5.5. Which of the following statements are true and which are false? Number 1, there can be a polygon with 2 sides. Let's try 1, 2. 1, 2. Polygon is always a closed figure, so this is false. A quadrilateral with all its sides equal is always a square. Not necessarily, because it could be a rhombus. Okay, so it is also false, right? 3-dimensional shapes. The objects that we see around us are mostly 3-dimensional, such as ball is an example of a sphere, a matchbox, an example of cuboid, a container, which is an example of a cylinder, a die, which is used in snake letter, is an example of a cube. Okay, all these objects are such that we can see them, feel them, and also they occupy space where they are kept. Such objects which are made up of 2 or more plane surfaces are 3-dimensional surface. Number 1, cube. A cube is a 3-dimensional shape with 6 faces. Each is a rectangle. Okay, it has 6 faces, vertices, number of vertices 8, and edges, if we talk about edges, 12 edges. Number 2, cuboid. A cuboid is a 3-dimensional figure having 6 faces, each is a rectangle. It also has 6 faces, 8 vertices and 12 edges. Okay. Number 3, pyramid. This is pyramid. Okay. This is a triangular base pyramid. This is a square base pyramid. Okay. A pyramid is a solid shape with base as a polygon and other faces are triangle. Some examples of a pyramid are shown in this figure. Number 4, cylinder. A cylinder has 2 plane faces, top and bottom as circles, and 1 curved surface, this. It has 2 edges but no vertex. A drum, a cold drink can, a lawn roller are all examples of cylinder. Number 5, sphere. A cricket ball or football are examples of sphere. A sphere has only 1 curved surface. It has no edges and no vertices. No more. Pentagonal base pyramid, hexagonal base pyramid, etc. can also be made, right? Number 6, a cone. An ice cream cone, part of a funnel, a birthday cap are all examples of cone. A cone has a circular base. This is the circular base and a vertex. It has a circular base and a lateral curved surface area. This is a lateral curved surface. Okay. Number 7, prism. A solid shape with a base as a polygon and other faces are rectangles, right? Example, a triangle base prism. This is a triangle base prism, and a square base prism, pentagonal base prism. Okay, no more. Cube and cuboids are special type of prism. They are called a square base and rectangular base prism respectively. Okay, let's do exercise 5.6. Okay, you have to fill in the blanks. Cube, number of faces a cube has 6, number of edges 12, and number of vertices 8. Okay, students, I hope you have understood this chapter. Now you will do practice of this chapter and of remaining exercise as well.